redirecting edge flow. All right, everybody, so we just have our plane grid here that we use for our examples. And in here I just want to show, like, there's times where you'll be working on something and you need to basically redirect edge flow to make some certain kind of cut. In this example, I went ahead and basically just did sort of a soft, like a soft turn. And the bevel on this is all going to be dependent on how close you put your holding edges to it. We'll play with that in a second. So in this case, I didn't actually have like any extra holding edges. In this case, I went ahead and actually ran the holding edges. Let's go select that again so you can see it. So you can see, like, I ran holding edges and then I tried to balance the mesh out. Not perfectly, but it's decent. And then so you can see the results, of course, when you smooth it, tighter bevels and stuff like that. Here I have one where I did the same thing, but then I turned it back out so you can kind of see how this would work. You know, let's say you're doing like sci-fi panels or something like that, and you needed like some piping or some kind of wires to like go in between this panel. Something like that could work. And then here's one where I did the same thing, but I went ahead and just tightened it up so it was a little bit more precise. This kind of modeling happens a lot, and I just want you guys to get used to seeing these patterns in your models so you can tell, like, okay, what do I do? How do I turn this corner and whatnot? So where do we start? Okay, so we start by just throwing some cuts in at 50%. Just do something like that, and then I'll just go ahead and connect that. And then I'll go ahead and just remove these extra edges that are superfluous at this point. And so now we've got this. This is a redirect. And if you go ahead and like select one edge ring and then double click on the next one, you can see it'll select through, and you can see that your edge ring is working. This will be different if you do it here. It will actually go up to here, and vice versa. It'll go this way. But this is what lets you know that you're kind of, you're getting the right direction. If you double click here and double click there, you're getting this edge loop that will go through. So once I've got those selected, I can go ahead and just do a little bevel here just to put a cut in there. And then we can go ahead and grab the faces. Now I can just select once, shift, double click, and now I can go ahead and just pull that down, or, let's go to 1. -1 is what I meant. -1, there we go. And we'll select these faces there and just delete those. And so now we're on our way to doing that. Now if I go ahead and I hit 3 on my keyboard here, you'll see that we're getting this valley in here that's curved. It's not like straight. And it's all about the holding edges. Remember, 3 points to a curve. So you got 1, 2, 3, and this is where it's going to average between 1, 2, 3. And on this side, it'll average 1, 2, 3 this way. And then also, actually, it's going to take into account where this one's going to. So 1, 2, 3 here, and then 1, 2, 3 here. So how do we change that? Well, let's just do little incremental changes here. And I'll go ahead and just throw a midline there. And then if I hit 3, now you'll see it's a little bit more flat when it gets towards the center, because we have 1, 2, 3 right here that are in line with each other, but these are still interacting with this part up here. Okay, so if you want to really hold it, then what you have to do is you'll have to drop something like that. And now you're isolating that curvature to 1, 2, 3 right there. So if I hit 3 on my keyboard, you can see this is completely flat. This area in the middle will be completely flat. Okay, so we go ahead and just take the same principle and we put it onto here, like so. And we'll do this, and then we'll do the same thing over here. I like to drop a midline first, and then I can just sort of eyeball the outside ones. And we can hit 3, and I do like to deselect and look at it without the wireframe on, so you can see kind of the curvature of everything and the highlights on the bevels and stuff like that. Another thing too that I should probably mention, this would be as good a time as any to mention, sometimes you're better off using something like a blend on this, because a blend has like specular fall off to it. Don't know why it's coming in looking like that. Let's do something like that so we can actually see. Yeah, so now you can really see those edges, right? It'll let you know if you've got any problems going on. We can tell right here that this corner is, when smooth, is different than this corner. Well, why is that? Because here we have basically the distance of this edge is greater than the distance of this edge. So this 1, 2, 3 curve is dictating the subdivisions, how much the subdivision surface moves when it averages out, whereas this one's just a greater space. So if we wanted this to actually hold closer, we would have to go ahead and add different lines in here, right? So for instance, I mean, you could, the way I did it up on these, let's go back to wireframe. I'll show you this one. So the way I did it up on here is I ran it off of the holding edge that I had on the edge here. I just ran all the way up. So then it would keep consistent with this holding edge, and vice versa. I did the same thing over here. But then when we get to the areas where this one comes across, I didn't really need that edge to be in the exact same spot because it wasn't necessary to hold this because I already had this one done. So I kind of ran it on an angle here just to try to balance the mesh out, because that's a lot of times important too. Why is that important? Well, and before I go ahead and show you what I'm about to show you next, let me just do this a little bit better because I feel like I could have balanced it out even better now that I'm looking at it. So I'm going to go ahead and just select this from here to there, and I'm going to go ahead and just maybe throw that just a little bit further over, like so, and then I'll just take this. Now I don't particularly like a stretched polygon like this down here, but it's more hidden. It's not going to be seen as much. And the same thing goes for over here. We're going to do the same thing with this, and we're just going to move this over a little bit more. Let me look at it from the top so it's a little bit more balanced. Okay. Yeah, I don't love these on an angle like this, but for the outer part, let's say you need to bend this into a shape, right? So here's another thing. So just think about this. Instead of having to cut this kind of thing into a tube, imagine you just cut it into a flat plane like this, and then you go to deformer and you go bend, and we'll go ahead and just rotate this because I need the deformer that direction. And then if I come to my channel box, I can go to the curvature and we can do something like that. And you can see it's pretty nice and balanced, right? So we have like this, it's pretty good. The more balanced your edges are here, the better. So that's going to be, your curvature is going to look better, right? But if I was to go ahead now and hit 3, let's see what it looks like. Let's deselect it. Let's get that wireframe off. Yeah, so we're getting like you could see there's a little bit of a pinching going on here. That might be something where you need to go in and fix that area, but it's not bad. It's not bad. But actually, so not even thinking about like modeling with the bend, but think about deforming this model with a balanced topology. You can deform a model like, let's say, the Hulk smashes into a panel or something like that. If this model is nice and balanced and you have it set up correctly, then when the Hulk smashes, you can basically have this model just have more geometry in it. So you can just go smooth like so, and then you've got this kind of topology, and it should be able to deform very, very nicely and very, very evenly, So that's basically why we want to like balance out our topology. Plus it looks good, right? It just looks nice like that. Now, if you're modeling for a platform, let's say for games, and you need it lower poly, okay, you don't have to obviously have all these edges run for that. But I am trying to basically implement a type of modeling here that can be used for games or for film, because in games you can use vertex alpha to paint in and out different materials too. So if you have a balanced topology, you could technically have materials like paint in and out on one surface, just with the vertex alpha, without having to use masks and stuff like that. You can use masks, of course, too. That's very common. But anyway, so just to finish this off, if I wanted to tighten up these edges, I can just go ahead and do something like this. Move this in. This thing is like being shiny now. It's sort of annoying if you have it at the wrong angle. You can move that in. And then we'll go ahead and just we'll move this to basically the same angle as the other one, or same distance, I should say, like kind of the similar distance from these points. And then here is where I basically ran a polygon. What I can do too is sometimes, if you want, you can just drop one point there, like so, and then you can run a polygon like this. You can just run it like so, and you can basically balance out your mesh later. So we just go ahead and take these three. You only really need the two. Do like that, and then you can cut this here to here. Hit enter, and we can do the same thing over here. So if you don't, there's not really much you can do about like when this thing when you cut and it comes in on a, it follows the angle. It's just the way Maya works. There are other tools that allow you to kind of negate that a little bit, but it just depends on which ones you want to play around with and try. There's like the offset edge loop tool, which is in the mesh tools. Offset edge loop and insert edge loop. You may be able to find some tools in there that let you negate that angle, having to fix this angle here. That one's a little bit off, I think. Yeah, you know why? Because it goes based on your screen. So basically, you have to have your screen face the right way, or otherwise it'll like basically cut based on the camera. All right, so now I'm just gonna grab this edge, delete that, and if I want, I can grab this whole thing and just go ahead and straighten that a little bit, and then I could see it moved over a little, so I'll just tidy it back up. And then here you can see like we have this this like real bad pinch. So why not we'll drop a 50% edge in the middle there, and why not just get rid of this edge right here. So we can just go ahead and double click, control delete, and there we go. So we've redirected again, and if we want, we can take this edge and balance it out with these edges. I won't do that for this because you know how to do that. You just pull the edge over a bit. But yeah, so you're gonna end up with a mesh that sort of looks like this. And then this up here is just basically doing the same thing twice. You're just going back up. And so there you go, that's redirection. Now, let's talk about organic modeling a little bit, okay? So I've got this panel in here, and I AI generated this. I just went ahead and put in some prompts for H.R. Geiger and a few other prompts. I got this little organic-y looking pattern coming out, and so I started to basically just lay a mesh over this. This is basically what it originally looked like. I was laying a mesh over this just with my quad draw tool. So I wanted to show that all the principles that I'm showing you, even though they seem like they're all hard surface principles, this all ties into organic modeling as well. And I think it's really important that you understand how to do hard surface before you get into organic modeling, so you understand the edge flow and how to connect things, and how to redirect stuff. And that this is basically where you could go with this. And now, instead of let's say this is a sci-fi wall panel, but instead of being sort of a hard surface, it's organic. That's where this could go here. I hit the wrong button. I meant to hit that one. Okay, yeah. So this one I just kind of pulled some of the edges up and then put a smooth on it, and you can see how that's starting to look there. I just did this quickly though. Like, this is not supposed to be like a finished product or anything. I was just trying to illustrate the possibilities of how, once you get this going, you can sort of start redirecting edge flow indefinitely, doing edge loops around things. And, of course, some of these you could add extra stuff in, and like if this isn't smooth enough, I can add an extra edge there or bevel this edge or something like that. I can try to balance these out so they're all matching each other. That's the kind of work I would get into if I needed to do like some really nice high poly, stuff like this. Now, me personally, if I got this panel and they're like, yeah, make an organic panel, I would take this into ZBrush or Blender or something like that, and then I would just like retopologize it probably. If it wasn't going to move or anything, you could just use Z-Remesh and you can get a nice quad geometry that just let Z-Remesh do it. But if it was something that needed to be very specific, like let's say these were all eyeballs that needed to like blink or something, well then you get into this area where you're probably going to need to actually by hand lay out the topology so that you can like blink the eyelids and stuff like that. So yeah, just wanted to bring up these other topics because they tie together. What you're learning in what you're learning in this area ties together in other areas. So okay, thanks for watching, and I'll talk to you soon. Bye now.